All right, here's example 1.35 from PreCalculus and the OpenStax text. We're kind of getting to the second topic now, I guess, from this section. The first topic being average rate of change, and the second one being more on the behavior of graphs. So things like increasing, decreasing, constant. What else do we talk about? Local maximum, local minimum. Anyways, this specific problem asks you to determine where this function is increasing. And I'm actually going to go a little further and tell you where it's decreasing and local maximums and local minimums. You could try to use these definitions, but as I mentioned in my summary videos, I don't think these definitions are very appealing to one's intuition. I mean, they work, and I think it's a good idea to understand why these mean the same thing as your intuition. But it'll be a lot easier for you to answer these questions just by using your intuition. Increasing means going up, and specifically going up if you're looking at this thing from left to right. So this graph is increasing kind of on this segment here, and then it looks like it's doing it again on this segment here. And anywhere I didn't just shade in, it's not increasing. In fact, it's decreasing. So how do you express that picture in your answer? Well, we're going to use interval notation, very bad handwriting. We're increasing. We're always going to specify the x values, the inputs to the function. In this case, we're using the letter t as our x values. And it looks like it's from when t equals 1 to 3. On our x-axis here, or t-axis if I'm being precise, between 1 and 3, this function is increasing. Note that you do not specify the y-coordinates or this point and this point. You just specify the x-coordinates, or t in this case. So it's increasing from 1 to 3, and again from 4 to infinity. You're like, wait, I thought with interval notation put a u in here. You put like a union. Typically you do. It's kind of nitpicky, but you don't want a u in this case because it's not increasing from 3 to 4, and if you put a union, you're calling it all one set. Don't worry about it. For your purposes, no one's going to mark you off for that little thing, but just because I'm a math teacher, I don't want to write something down that's wrong. To make this answer look right, I would say it's increasing on this interval, and it's increasing on this interval right here. And therefore, here's a bunch of questions this did not ask you. Your function is decreasing from negative infinity all the way up to positive 1. And note, that's talking about these t values here. So I'm talking about in this interval right here. It's decreasing all the way until I get to here. I'm not talking about the heights. We're just talking about the x values or t values. And then there's another interval that's decreasing on. It looks like between 3 and 4. This function is never constant. Just as the solution said here, it doesn't get flat. There's no points where it's not increasing nor decreasing. There are some local maximas and local minima. Let's see, I got a valley, I guess you could think about it, here and here. And I have kind of a little mountaintop thing here. So I could say there's a local maximum. And I'm going to specify the point. I'm going to say at the point 3, 1. You can specify your local maximums in lots of different ways. You can say it is at 3 and the local maxima has a value of 1, or you can specify the point right here. I'm going to do the points just because I think it's a little bit easier to understand. Local minima, well, I got one here when the x coordinate, or t coordinate in this case, is 1 and the height is negative 1. But then I got another one right here at 4, 1. No, 4, it's less than 1. I don't know, 4 1/2? It's less than 1/2. 0.75 maybe? Try to write that a little bit neater. And that's just an estimate. That's me ballparking it by looking at the graph. That looks to me to be approximately 3/4, not quite up to a height of 1. Again, this question didn't ask all this stuff. It only asked about increasing, but I figured as long as I'm here, I do an example and talk about a lot of different stuff.